All right, and we are good to go. All right. So part of yesterday, I gave you the solutions. So I don't really think there should be that many questions from yesterday, hopefully. I'm assuming that's true. Plus, I wanted to spend all day today talking about writing proofs. All right, so that's where we're going to begin. Again, feel free to jump in if you're having trouble, my homeschool guys. All right, but here we go. Number one and number two are two of the basic postulates in geometry. All right, number one, the ruler postulate. I'm just going to read it. I don't think I've ever written the ruler postulate as a reason on part of the proof, but I think it's important. All right, it says two basic postulates for working with segments and links are the ruler postulate, which establishes number lines, and the segment addition postulate, which describes what it means for one point to be between two other points. And we've talked about this. All right, so basically the ruler postulate says this: the points on any line or line segment can be put in a one-to-one correspondence with real numbers. All right, what in the world does that mean? A one-to-one correspondence. That means point A can't be located at two different points. All right, does that make sense? And of course, I used to call these common sense. All right, that makes perfectly good sense to me. Point A can't be located at 1 and 6. It can only be located at one point. That's basically what the ruler postulate says. All right. Now, the next one is the one we're going to use all the time, which is the segment addition postulate, which basically says if A, B, and C are collinear, then B is between A and C if and only if AB plus BC equals AC. That is called the segment addition postulate. That is called the segment addition postulate. And again, we've already discussed that. All right. And we used to call it the sum of the parts is equal to the whole. All right. But again, to me, that was shocking that that couldn't really be proven, that we just had to accept that as true. All right. Now let's go ahead and start our first proof together. And I personally think when you write the statements and then you give the reason, sometimes it's harder because you have to do it exactly how they say to do it. All right. I prefer to write it my own way. Sometimes it's easier. All right, but we're going to start by just filling things in, and then eventually it'll be completely blank and you'll have to reproduce it on your own. All right, so let's go with this and see what's going on. All right, first of all, Q is the midpoint of PR. R is the midpoint of QS. We're trying to prove that PR is congruent to QS. That's what we're trying to prove. All right. Now, I personally think it's better just to think about it, all right, first before I do the proof. So if Q is the midpoint of PR, what does that mean? Someone tell me. Tell me. That is correct, but because it's the midpoint, something more specific than that. Sam? Yes, but we're going to say congruent. PQ is definitely congruent to QR. All right, now let's look at the next given. R is the midpoint of QS. So what can be true now? Tell me. QR is equal to RS. Does everybody agree I put a 1 tick mark on QR, right? So I can put 1 tick mark on RS. Does everybody agree with that? So now, what is true about PQ, QR, and RS? They're all congruent. To me, that was obvious. Now, does everybody see that PR has to be congruent to QS? Can you just look at that and tell me that's true? Yeah, I can look at that and say, obviously that's true, right? But now we're going to do what? Yeah, we're going to prove that it's true. We're not just going to say something's true because I can look at the figure and say, obviously it's true. All right, that's what's difficult. That's what's difficult. All right, and It's going to be annoying at first. If you do the proofs, they will get easy. If all you're doing is writing in the information and not thinking about what you're writing down, it's going to always be hard. All right, so as soon as you don't understand something, just tell me, and I can try to say it again. I can try to say it slower, or we can do it different ways. All right, but this is what you have to do. You have to participate, not just writing things down. All right, now generally when you do a proof, I personally just write all the given down first. All right, but in this particular case, they don't. All right, so what did they do first? Q is the midpoint of PR, so that is what? Given. That is given. All right, so here we go. Given. All right. Now, why is PQ equal to QR? What do you think, Davis? Yeah, you can say that, or we could just say that's the definition of what? Yeah, definition of midpoint. And like I said, I do think this is very simple. Definition of midpoint. R is the midpoint of QS. Why is that? Given. And then what? QR is equal to RS. Again, same thing. Definition of midpoint. All right, how are we doing at home, you guys? Everybody's good? You guys don't be afraid to just... All right. Okay, so I'm happy with that. Oh man, I forgot. I'm sitting here screaming. All right. So now, here is generally what you do. All right, the next step, it says PQ is equal to RS. Tell me.
Definition of congruent.
Now, definition of congruent, and that's good, so I want everybody to listen because we're going to use this a bunch. Definition of congruent means when you go from congruent to equal. All right, that's the definition. All right, someone else, give me a thought. Substitution, I like that. Substitution. What else was I thinking of? Transitive. All right, so now let's look at why we could call it the transitive. And once again, guys, if you write transitive and I write substitution, who's right? Both of us. All right, I don't care. But I'm going to try to show you now exactly why it's called the transitive property. So please watch. I'm going to highlight, and you can see for yourself. PQ is equal to QR, right? Then we say QR is equal to RS, correct? So therefore, PQ has to be to RS. That's the transitive property. Now, for me personally, I used to tell kids, it's got to be in that exact order, or it's not the transitive property. It would be technically the what? Substitution. But we could say, because QR is equal to PQ, I can substitute in for QR, PQ. Did everybody see that? Do I care? I don't care. Please do not ask me if I put transitive and you put substitution, is it wrong? You're not listening. No, it's not. All right, so you decide. All right, technically this is a good case for transitive property. If you put what? Substitution, I'm happy. All right, now the tough part. Now the tough part, number 6. Come on, everybody participates. So now, I always try to show kids, we're using the other information right above it to generally look at what's next. What do you think? Yay, very good. Addition property. Right now, how did we know that? Because look at step 4. and step 5. What did we do there? We just added them together. If two things are equal, when you add equals, you're still going to get what? The equals. So we're going to say the addition property of equality. The next one looks a little peculiar to me. And the reason it looks a little peculiar because I'm looking at the statement above and I don't see how they used it to get to here. So I need help on this one. What do you think, Olivia? Yay, very good. Now this is a case where I would have put this one way above. All right, but they think a little bit differently than me. So they did a little bit differently, but they still did it correctly. All right. So does everybody agree? This is the segment addition postulate. Does everybody agree? Tell me. Because look, the parts PQ plus QR definitely equals PR. That's what that says. Do you see that now, Morty? I'm right here. I'm right here. This statement right here is the segment addition postulate. You see it now, right? Now, again, I was confused when I first looked at this proof because that's not the way I think. I think that should have been at the very top. You agree with me on that? All right. So again, sometimes I think they go out of order and I would not have written it out like this. All right. That's why I'm saying I like doing my own proofs. All right. I don't like to follow anybody else's. Go. Yes, that comma. We could put that below and say number 8, right? But generally when they do that, that means it's the same exact reason. You with me on that? Does everybody see segment addition postulate, right? Segment addition postulate is commonly known as SAP. Abbreviations are okay. All right. So now, why is PR equal to QS? Yeah, it is a substitution, whoever said that. Exactly, because look right here, guys. Look right here now. I'm trying to highlight so you can see it, because sometimes I know when we're first getting started, it's kind of hard. What does PQ plus QR equal? Wait a minute. I ask you a question. What does PQ plus QR equal? PR. So I'm replacing, now I'm highlighting, getting it darker. I'm replacing that with what? There it is right there. You with me? Now that's part of the reason why I like my iPad, because it's easier. Now look at this right here, guys. What is QR plus RS the same as? So I'm showing you right here how it's substituted in, right here. That's a substitution. All right, so we're going to put substitution. That's our first proof, guys. That wasn't that hard, right? Not too hard. All right, but again, I'm telling you, it's just important that you participate and understand what you're writing down and not just writing the information because you're repeating it. All right, you got to understand what we're saying. All right, so let's just continue on now. Let's look at number 1 and number 2 on this worksheet. All right, here we go. Let's see if we can do this. Now, this one's a lot different because it says it's only how many steps? 3 steps. So let's see how we're doing. Given BC is equal to DE. Now, notice again, BC is equal to DE, so that's your clue that it's what? Given. Now, we are trying to prove AB plus DE equals AC. So I'm trying to prove that AB plus this down here is weird to me, is equal to that. All right, Morty.
How do you know if something is given?
Well, look, I mean, again, I'm not trying to be funny because you with me, but it says given.
Oh.
All right. So, you know, listen, Warrior, I please, all right, it's all right. Okay, don't. And again, I'm telling you, this is the first time you're doing proofs. And listen, if you want to be good at math, this is what you have to be good at, honestly. All right, wait till you go to college and major in math. It was amazing. All right, it's really cool, actually. All right. But right now, we're at the basics. You're just starting out. So you have to ask me everything. And even if it's at the expense of looking a little silly at times, all right? Don't be afraid to ask if you want to be good. All right, yes, sir.
It would be AB plus DE equals AC.
Wait a minute now. I'm trying to fill in number 2, right? But now they're telling me that it is the segment addition postulate. Jump in here. Yay, I like that. Let's see. A, B, uh-oh, what are they doing? AB plus BC equals AC. Now I'm really trying to show you how you look at the, most of the time you look at the one right above it and say, so now I'm trying to highlight something for you so you're with me. Up here and down here, what's different? The DE has been replaced, the BC has been replaced with what? So it's probably a what? It's probably a substitution. I mean, I'm telling you, that's how simple it is. And every year I hear whining. Oh, this is so hard. I don't think it's that hard. That is a substitution. Now, does everybody understand? That's not the transitive property, right? I can clearly see the difference between a transitive property and a substitution. Sometimes they look very similar, right? Is everybody good on that? Yes, sir.
Could you specify the difference a little bit more?
The difference? Yeah, okay, so here we go. Here, I was just watch. I'm gonna try to make this clear, all right? Here, I was literally just taking the BC and replacing it with DE. The transitive property says, it would say, for example, like A is equal to B and B is equal to C, then A would be equal to C. You with me? There's now, again, I have a lot of kids say, well, can I just take this B and put A in? That's a substitution too, right? But here I wasn't comparing 3 things, kind of. You agree with me? All right. All right. Again, I really don't care. All right. I care about you getting the idea about how to do a proof. All right. So let's try this guy over here now. Okay. Now, given Q is between P and R is between Q and S, and PR is congruent to QS, or equal to, I should say. So when somebody says equal, I just go ahead and mark that right on my figure, right here. That's the only thing I know for sure, right? Okay. Now, of course, we have step 1 is given. All right, Jude, tell me why PQ plus QR equals PR.
The addition postulate of equality.
Close. They're segments, kiddo. Now, see, what I want you to think about, I want everybody, not just you, but they said PQ plus QR is equal to PR. Right? That is the what? SAP, segment addition postulate. Step number 3. Harris, what are you thinking about number 3?
Is that
And if you can't see it, we'll ask Morty.
yeah, I can't see it.
What is it, Morty?
I pass it on the phone.
Come on, what are you talking about? Doesn't it say R is between Q and S up here in the given?
I didn't see
Man.
that one either.
All right. Here we go, Harris. You with me? That was
So
the
is it, gi-
one.
is it given?
Yeah, brilliant. Given. Jump right in there. Save us. Given. No, you won't. Watson's going to tell me the next one. Yes, you are. You're good. You got it. QR plus what? Yeah. Come on, God. Look, man. Seriously, guys. You got to get over being wrong. All right? No one cares. Just say something. You might surprise yourself. Morty, right?
Yeah.
You might be right once. All right? So again, there's the segment addition postulate there. All right? That's good. No problem whatsoever. All right. Now, Morty, jump in on number 5.
All right, I'm looking at that. Yeah. Given.
Given. Yay. We got it. Harris, are you with that?
All the way.
All the way. All right. We are all the way. Given. Nice. All right. Now I need some help. AC, tell me. Now, what in the world are you talking about substitution on that for? How did you see that? Yeah. Now listen, I don't understand how people don't see that, but I know people don't see it. All right. I personally just going, that's just so simple, so obvious. All right. And some of you are going, God, he always says that. It's so annoying. Right? You have to look. Yes, I know how you feel. Trust me. You have to look. So I'm asking you, they're telling you that PQ plus QR, right? PQ plus QR. Where else is that? I'm going to change the highlight on that. PQ plus QR. PQ plus QR. What is that? Right, because it's saying right here, PR changed to what? PQ plus QR, right? And then we say QS, right? QS is the same as what? QR plus RS, so I substituted that. Is everybody with me? Now again, trust me, I know it's not always easy to see, all right? That's why I'm drawing and coloring and showing you. All right, if you're not quite seeing it, you got to be more patient. You got to keep trying. So we said that was a what? Substitution. Now, well, obviously, everyone knows the next one, right? Tell me. Yeah, subtraction property of equality. Now, again, we notice there was a QR on both sides. There was a QR on both sides. So I was trying to eliminate them. And then what is left? PQ is equal to RS. Now, again, I'm not too happy with that substitution, but what are we calling, why is it called a substitution? Does anybody remember what I said? Because when you subtract the QRs minus QR, it equals what? 0, right? So essentially you're substituting 0 in for QR minus QR. Does everybody agree with that? All right. So there you have it. That's a pretty good proof. What? We used to call it simplifying. You know what I mean? We just simplified. That's what it was called. What?
So on like the quiz or test, is it gonna be like this?
Yeah,
is it
yeah.
all gonna be blank?
Well, right now they're going to be fill in, but then in a month you're going to be writing 15, 20 statements and reasons proving things.
Okay.
All right. It seems hard at first, but it's not. It's not. Okay, so I'm pretty happy with that. All right. What time? How much time do we have?
13 minutes.
We got time. Let's continue on. All right. Here we go. And this is a lot here, guys. So let's go. Let's get the move on. All right. Here we go. Let's try the next one again. And here we're reviewing reflexive property, symmetric property, transitive property. All right. Write a 2-column proof. AB is congruent to DE. B. So here we go. Let's write it. AB, now notice what I'm doing. AB is congruent to DE. And then what? BC is congruent to what? EF. And we're trying to prove that AC is congruent to DF. Does everybody agree that's obvious? Right, everybody should say that's obvious, common sense. Why do we have to prove it? Because we want to get better, that's why. All right, so here we go. Why is AB congruent to DE? Given. All right, here we go. Now, everybody knows this. Why is AB equal to DE? Definition of congruence. Definition of congruent. Now, they use that, and you can use the symbol there. Oh. Definition of congruent. All right, here we go. Definition of congruent. Now, again, you can say definition of congruent to go from equal to congruent or congruent to what? Equal. All right. So now, why is BC congruent to EF? Good. Given. Why is BC equal to EF? Definition of congruent. Okay, so now I'm looking here. AB plus BC, AB plus BC, and then I have DE plus EF. So what are we doing? No. No. Say it, somebody. Karina. Yeah, addition, property of equality. Right now, I understand that's kind of tricky to see also, but do you agree if AB is equal to DE and BC is equal to EF, you're just adding them together, right? Now, it's not a segment addition, right? We're not doing segment addition because we're adding equals, all right? And if I had time, I'd flip back and show you that's the addition property of equality if you can't see it. And that was from our notes yesterday. Addition property of equality. All right, now we got it. Who haven't I heard from today? Come on.
How about an onliner?
How about an onliner? Go onliner. Lorenzo, go. What is number 6?
Substitution.
Definitely. Now listen. AB plus BC equals AC. Look at the figure. AB, why is AB plus BC equal AC? Tell me, Mr. Varner.
Segment addition.
Yes, otherwise known as SAP. Lorenzo, are you okay with that?
Yeah.
All right, and the same thing obviously over here. Same policy, DE plus EF equals DF. Okay, what is the next 7?
Substitution.
Why is that substitution? Right, so now look right here. Again, I'm trying to make it clear because it's not. And I used to think it was clear, and then, you know, we had some hurt feelings. So you know how I'm not trying to hurt your feelings. But here we go. This AB plus BC is the same as what? Is the same as AC. Right? Does everybody see that? Yeah, AC. Funny joke, right? Here we go. Over here. DE plus EF. That's the same as what? DF. So I'm doing a substitution. Does everybody see that? All right. So here we go. Substitution. And then finally, step 8. Yeah, definition of congruent. All right, measures are equal. Sides are congruent. All right, I'm feeling pretty good about that. All right, let's knock out another one real quick. Let's knock out this one, and then you have that for homework.
Given.
All right, slow down there, Morty. All right, justify each statement with a property. Oh, okay, I almost missed this. Number 1, these are just 3 individual questions, guys. I almost missed that. All right, if DE is congruent to GH, then GH is equal to or congruent to DE. What is that? No,
Reflective.
no, no. Symmetric property. Well, okay, for those of you guys that didn't see at the very beginning, here it is,
I see it now.
right? Symmetric property, all right? Symmetric property. All right, now we're reviewing number 2. If AB equals RS and RS equals WY, then AB equals WY. That's obviously transitive. Don't ask me if it's substitution. And why does RS equal, or why is RS congruent with RS? That is the reflexive. You are always equal to yourself. Reflexive property. All right, another obvious statement. All right, believe it or not, it wasn't always obvious. All right, here we go. So now let's knock this out quick. PR is congruent to QS. Given. PR is equal to QS. All righty, guys. Why is PQ plus QR equal to PR? SAP. So
QR plus R.
what?
QR plus R. Yeah, equals QS.
That a boy, Morty.
Marty.
QR plus RS is equal to QS. Thank you. Segment addition postulate.
Addition equality.
Wait a minute. Wait a minute. What is that next step?
Addition property equality.
Ooh, I don't know. What is it? Okay, now let's try to figure this out. Okay, so please look. And again, I'm not saying right or wrong. I'm just saying please watch, and you can try to get the difference. So up here, they're telling you that PR is equal to QS, right? So now we know that PR is the same as PQ plus QR, right? So I'm replacing PR with PQ plus QR. And then I'm replacing what? There you go. All right. I'm replacing this into here. That's why it's the what? That's why it's substitution. All right. And then we would simply say PQ plus QR minus QR equals QR minus QR plus RS. And that's subtraction property of equality. And then, yeah, see, so this is where I think it was a little confusing. So please watch, right? I'm going to, listen to me. This is how I normally do it. I was thinking back to their other step where they actually showed the subtraction property, right? Does everybody remember that? They showed the subtraction property. Here they're just saying what? They're saying PQ is equal to what? RS. That's the subtraction property. Is everybody with me on that? Yeah. You see what I'm saying, right? Yeah, QR cancels. And then equal becomes what? PQ is congruent to RS. All right, guys, that's a good day. All right, that's a good day. Now, please try these questions here. Try these here. All right. And again, If you're having trouble, please look back because they're kind of similar in many respects. But I'm just trying to tell you from years of experience now, if you don't try, you're never ever going to get better at it. All right. Just because you don't know one step doesn't mean you can't follow another step. All right. Anybody have any questions? Guys, I appreciate it very much. And tomorrow I'm going to do the same thing. I'm just going to walk around and kind of check. Yes, sir. What's that? Yeah, the rest is the homework. All right. That's what I want you to look at. All right. Try those. All right, my homeschoolers. Thank you for a great day. All right. Does anybody have any questions?
No.
All right. Appreciate you guys very much, man. You guys have a nice day. I'll see you all tomorrow. And I am going to post the video just in case you want to hear me again.
All right, bye.
Bye-bye, guys.
Thank you.